So in this lecture, we're going to look at some examples of how we can use conversion factors for mass and weight to answer some practical questions. We're going to see some other ways that this dimensional analysis technique we've been using uh, can also be helpful. So my first question here, we have a pickup truck and we know what its carrying capacity is. It's 1,500 pounds. And we need to move some flooring tiles, and we know how much each individual tile weighs. It's usually on the box or the distributor's website. What I want to know is how many of these tiles can I carry in my truck? So the first thing I notice here is our biggest challenge is going to be that the units are mixed. The carrying capacity of the truck is in pounds, where the weight of the tiles is in ounces. Right? And you never want to be mixing and matching units when you're doing any kind of calculation. So the first thing I'm going to do is I'm going to convert those ounces into pounds. Okay, so I have 12.1 ounces, and this is actually a, a kind of a conversion factor here. It's 12.1 ounces per one tile, and I need to convert this into pounds per tile. So to do that, I'm going to use my pound conversion factor, pounds to ounces. There's 16 ounces in 1 pound. All right, so if we do the arithmetic here, you notice the ounces cancel. And we know that there are 0.75625 ounces per, excuse me, not ounces, we converted it, right, as pounds per tile. All right, so I need to know how many of these things I can put on my truck. All right, well, the truck holds 15, it carries 1,500 pounds. So what I need to do here is I need to get this into tiles. So I'm going to take 1,500 pounds and I want the pounds to go away and I want to keep the tile. So I have one tile. This is my conversion factor that I just calculated, 0.75625 pounds. And you notice here the pounds are going to cancel. And 1,500 divided by that decimal is 1983.47. Now this is a situation where it wouldn't matter to me what that decimal would come out to. It wouldn't matter to me if it was 1983.99999. I would still round this down, right? Because if I round it down to 1,983 tiles, then I'm going to be a little under my carrying capacity, which is fine. If I had rounded it up, then I'd be a little over the carrying capacity, and that's a little sketchier, right? Even if it's just by a little bit. So I'm going to round this down to 1,983 tiles. Now I need to know the second part of the question. How many cases is this? Well, there's 10 tiles to a case. And again, it's kind of a conversion factor, right? I have 10 tiles in one case. Right, so I'm going to take my 1,983 tiles and I want to convert this into cases. So I'm going to put tiles on the bottom. Right, remember that's what we always do. The unit that we want to get rid of goes on the bottom. The unit that we want to keep goes on the top. So it's 10 tiles per one case. 1983 divided by 10 is 198.3 cases. And again, rounding with something like this, rounding up is generally going to be a bad idea because that has the potential to put you over your limit by a little bit. So I would say the truck can carry approximately 198 cases. So we've got another question for us here. This one involving medication dosages. The way medication works, some medications work, how much a patient should get depends on their weight. Okay, so you see that here. There's 7 milligrams of medication per kilogram of patient weight. So when I write these, I'm going to be more specific than just kilograms. I'm going to say it's 7 milligrams that's patient weight. Excuse me, 7 milligrams. That's the medication. 7 milligrams of medication weight per 1 kilogram of patient weight. So I know my patient is 175 pounds. Okay, so I need to get those pounds into kilograms, right? So I can do that with my conversion factor here. 175 pounds times, and I'm going to want pounds on the bottom so they cancel. I'm going to want kilograms up on top. So it's going to be 1 pound per 0.45 kilograms. And this is where we got to keep these straight. This is patient kilograms. And what I'm looking for is how much the patient should receive. So I'm looking for milligrams of medication. So I've got my conversion factor here, right? I know I want to keep kilograms. Oops, excuse me. I want to get rid of kilograms of patient weight, and I want to keep milligrams of medication weight. So my conversion factor here is 7 to 1. So check out the units, right? The kilograms of patient weight cancel. All that's left is milligrams of the medication. And if you do the arithmetic here, this is 551.25 milligrams of medication. So I've got a very similar question here. We've got the same idea. We know milligrams of medication per kilogram of patient weight, but now we also have this per day part, right? And I want to know how much the patient is going to need for a week. All right, well, here's how we'll do this. I'm going to take the 210 pounds, and I'm going to convert that into kilograms, just like we did before. So it's 1 pound per 0.45 kilograms. Now, let's see how we can use this part here. There's 2.5 milligrams of medication per 1 kilogram of patient weight per, see, I'm just going to do another division here, per day. So now the pounds are going to cancel, the kilograms are going to cancel, and we're left with 236.25 milligrams, that's the medication, milligrams per day. Okay, now it's easy to get to weeks. I'm going to take 236.25 milligrams per day, multiply that by 7 days per week, and we get 1,653.75 milligrams per week, which is exactly what the question asked for. So in the next lecture, we're going to move on to a new topic. We're going to look at how you can do conversions between the two commonly used temperature scales and a less commonly used one, but it's also really important in science applications.